Hello grade 9 students. Today we'll do another geometry lesson with you. That's chapter 8 in your textbook. That's angles related to straight lines and parallel lines. So we'll revise all types of angles and some of the theorems here. Take a look at this one. What is an angle? When two straight line segments are met, an angle is formed. These two straight line segments are referred to as rays. So these are the two straight lines. So you get an angle here. So what you call the two lines? Rays. So what are the rays here? AB and BC. And the point where the two rays intersect, what is this point? We call it vertex. The three letters of the English alphabet are used to name an angle here. So what are the three letters? A, B, C. So angle can be named as A, B, C. So you have to start from either here or from here. So you can write A, B, C, and we are putting a hat there to represent that's the angle. Or I can write C, CBA. CBA. And also if you don't get another angle, we can just write angle B. So this is how we can write down angles. The unit of measuring the angles, we use degrees. Degree. What's the sign? So we put a small circle as a superscript. So for example, if this is 80 degrees, 80, and then we put a small circle there to represent degrees. Another way of defining angle, rotation of a line segment. Take a line segment around a point. So if this is a fixed point, we are rotating this one, so you get an angle. So this is the angle here. If you rotate the entire circle, what's the value? That's 360 degrees. So if you take one full circle from here, if you rotate up to this point, you get 360 degrees. Now we'll look at types of angles. Acute. Acute means the angle is less than 90 degrees. So learn these words correctly. Acute. And then you already know this. Right angle means angle is 90 degrees. How can you write down this angle? I can write ABC. B is the angle. Here also ABC. B is the angle. That's 90 degrees. Obtuse. What is obtuse means? More than 90 and less than 180. So KLM is the angle here. That's more than 90 and less than 180. Then what about this one? Straight angle. Straight means straight line. You get 180 degrees. Then what's the other type? Reflex angles. That means more than 180 and less than 360. So you get either more than 270 this way, the reflex angle, or less than 270 and more than 180, you get this type of reflex angle. Then you need to know this word, adjacent angles. Adjacent means next to each other. So when you take this diagram, this is the common line. BP is the common line. So we call common arm. This is the common arm, BP, and this is the fixed point according to this one. So you get two angles, adjacent angles, both ways common to common arm. So what are the things that you need? Common arm, common vertex. So this is the common vertex. And angles situated on opposite sides of the common arm. So this way and this way. So what are the two angles, adjacent angles? How can we label? ABP. ABP and PBC. PBC angle. Or other way around. I can write same thing, PBA. I can change these two letters. Or I can write here CBP. Now identify adjacent angles here. This is the common vertex. This is the PQ is the common arm. You get angles both ways. What's this angle? APQ. I can write APQ and QPB. QPB, both are adjacent angles on AB straight line. So what's the common arm? PQ. Common vertex is P. Theorem number 1. The sum of the adjacent angles of a straight line is 180. So this is a straight line AB. These are the two adjacent angles. So that's equal to 180. So you will learn another name for that. It's supplementary. 180 means supplementary. So that is equivalent to two right angles. Two right angles means 90 plus 90, you get 180. So according to this diagram, this is straight line AB, APQ, that's one adjacent angle. The other one is BPQ equals to 180. That's the first theorem. When you get a straight line, the sum of adjacent angles add up to 180. Now we'll apply that in several examples. This is a straight line. Find the value of x. We know the sum of two adjacent angles add up to 180. Now subtract 100 from both sides. You get 80 here. This is x. So what's the value? 80 degrees. This one, three adjacent angles are there. So we can use the rule. Sum of adjacent angles on a straight line. So 2x, 3x and x. The sum is 180. Add it. Like terms you can add. So 6x is 180. Then divide by 6. You get x equals 30 degrees. Determine the value of x here. This is a straight line. 90 is there. This means 90 degrees. So sum you can take as 180. 90 plus 50 plus x equals 180. 80. That's theorem number 1. '90 plus 50, 140, and subtract 140 from both sides. You get 40 here. So x equals 40 degrees. Now another word, vertically opposite angles. Vertically, pair of opposite angles are formed by intersecting two straight lines. So when you get two straight lines intersecting, you get opposite angles. What are the opposite angles? When you take any two line, is like X letter. One angle is here, the other angle is like this. So these are opposite. If you take this one, this is opposite to this angle. Now identify what are opposite angles. If you take A and C, opposite angles. And then this way, B and D. Now we'll take theorem number 2. When two straight lines are intersecting, the opposite angles are equal. So we'll see how we can prove that. So that means they are saying A is equal to C, B equals D. So we'll take AB line. If you take AB line, that's a straight line. We know A plus B is equal to 180 according to theorem number 1. Sum of angles on a straight line is 180, theorem number 1. Then again we know if you take this line, CD line, that's also a straight line. B plus C is also 180. That's also theorem number 1. Now look at these two statements. This is also 180, this is also 180. According to the lesson axioms, if one side is equal, you can equate to the other side. So that means axiom number 1. So you can write according to axiom number 1, A plus B is equal to B plus C. Then subtract B from both sides. What happens? Take away. So you get A plus B minus B, B plus C minus B. You will end up with A equals C. So that means this value is equal to this one. So similarly, I can write like this. Similarly, you can show that if these two are equal, definitely B is equal to D. So what's the second theorem? When you get opposite angles are equal. Complementary angles. What are complementary angles? Two pairs of adjacent angles add up to 90. So the sum is 90. Sum is 180 is straight angle. Now sum is 90, complementary. If one angle is 30, what should be the other one? 90 minus 30, that's 60. If this is 40, that should be 50. If this is x, this should be 90 minus x. So these are complementary angles. So according to this diagram, ABD and what's the other angle? DBC. That's add up to 90 degrees. 60 plus 30 you get 90 degrees. Supplementary means the sum is equal to 180. So two adjacent angles add up to 180, we call supplementary angles. If one angle is 100, what's the other angle? 180 minus 100, you get 80. If one is 10, other one is 100. What's the value? When you subtract 10, 170. If this is x, what's the other angle? 180 minus x. Now when you look at this diagram, this is a straight line. So add up to 180. PBA plus ABQ. This is a straight angle and that's called supplementary. That's 180. Angle at a point. So when you take angle at a point, we know that around a point the sum is 360. The sum of all the angles around the point O is 360. So you can write A plus B plus C plus D plus E is equal to 360. Now you are learning another word, transversal. What are transversals? A straight line that is drawn to cut two or more straight lines is called a transversal. So these are the two straight lines and there is a line across that. So what's the transversal? In this one, AB is the transversal. What about the transversal there? So this is two or more straight lines. So these are the three straight lines and across that there's a line PQ. So PQ is the transversal in the other diagram. Parallel lines, how you identify parallel lines? If two straight lines does not intersect and the vertical distance between the straight lines is always equal, they are parallel straight lines. So that means PQ distance, this is the perpendicular distance in between parallel lines. If these two lengths are equal, if PQ length is equal to RS, we say AB and CD are parallel lines. So we can use this symbol also to show parallel lines. AB parallel to CD. In grade 10 and 11, we are using this symbol to represent parallel lines. Look at this diagram. In this figure, two straight lines L and M intersect at points P and Q. And N is the transversal. We call the line intersects two or more lines intersecting with another line. We call that's a transversal. So in this one, N, this line. This line is the transversal. What about this one? Identify the transversal. In this figure, these are the lines and intersecting at P and G. So this one, this line is the transversal. So N is the transversal there. What about this one? Can you identify a transversal? There's no transversals, all like intersecting at a point. But in this diagram, you can see N. This one is the transversal. In this figure, APQ points are on the transversal And can you see that? This Q point is in the outside region and these two are intersecting with the other two lines. What about this one? In the figure, AQP points are on the transversal. So this is the transversal. N is the transversal. So this is the transversal. And A is located outside the two straight lines L and M. So here this is outside the region. So when you take a transversal with two or more lines, we can define regions. We call this is the inner area and this is outside area. So we'll talk about that in the next slide. We'll talk about that one in next slide. Look at this one. In the figure where PAQ are located on the end transversal. So where's the transversal there? This is N. This is the transversal. Point A is situated inside the two straight lines. So this is A inside and LM, that is called internal area. So this one we call internal area. So this part I'll show you later. This is called internal area. So here this is a clear diagram. This is the transversal and two lines. So we call this is the internal area and these two are external area. So the internal area is shaded. This is also two lines with the transversal here. So internal area is here and external area is outside. Angles related to transversal. When you get a transversal, you get different types of angles. So the first one is alternate angles. So what are alternate angles? When you get a transversal here, this one. So here, this one with this one. So when I draw the diagram, what is the letter you are getting? What type of letter? In this one, this one and this angle. So identify what type of letter here and here. This one, so something like this. Here and here, here and here. Z letter, like Z letter, other way around C letter, you get these two. So these are called alternate angles. The alternate angles are located on both sides of the transversal. When you take the transversal, one angle is this side and the other angle is on the other side. So located on both sides of the transversal in the internal area. Now you know this is internal area. So alternate angles are in the internal area. So what are the two angles there? Alternate angles A and B in the first diagram, X and Y in the other diagram. So this is like Z letter. Another type, corresponding angles. This is the transversal and identify this and this. What type of letter you get? And here this angle and this angle. So like F letter. So here this one, this is the transversal and here F other way around. So F letter, when you take F letter, these two angles. or F letter other way around. This and this. What about this one? This is the transversal, and here these are the two lines. So here F letter other way around. So what are the corresponding angles there? AB are corresponding angles as well as E and D. So remember F letter. Now what can you say about this diagram? Corresponding angles are on the same side of the transversal. So if you take transversal on the same side. Here when you take the transversal, you get E and D, both are in the same side. P and Q are corresponding angles. These two. This is the transversal. R and S also corresponding angles. So this is the transversal. An angle is located above or below the straight line in the external area, and the other angle is situated above or below the rest of the straight line in the internal area. If one is outside, the other one is inside. Here this is outside, this is inside. The two angles are arranged on the same side of the transversal. So F letter, remember for corresponding angles. Now another type, allied angles. So allied angles are in the internal area. So here and also here internal area, these two A and B are pair of allied angles in this diagram. X and Y are the allied angles in the other diagram. A pair of allied angles are always on the same side of the transversal. So this is the transversal here, this is the transversal. What's the letter here? You can remember like U letter. U letter this way here. These are allied angles here. Something like this. U letter, C letter. You can remember for allied angles. Look at the diagram. Pairs of alternate angles. Identify. Alternate means Z letter. If this one is there, the other one is F. D and F. What else? C with E. C and E. What else? That's all. So one is, if you take the transversal, one is one side and the other one on the other side. Pairs of corresponding angles. If you take D, which angle correspond to that? That's H. D and H. If this is C, C with G. This and this, here and here. What about if you take E? E as one angle, then what is the corresponding angle? That's A. If this is F, what's the corresponding angle? That's B. Now identify pairs of allied angles. That's like U letter. Inside the two lines, that means internal area. D and E. Or you can take this side, C and F. So you need to remember what are alternate, corresponding and allied angles. Letter wise, this is Z letter. This is F letter for corresponding and U letter for allied angles. Angles related to parallel lines. So theorem number 3. That's what it says. When a transversal intersects a pair of parallel lines, the corresponding angles formed are equal, the alternate angles formed are equal, the sum of each pair of allied angles formed equals 2 right angles. So that means 180. So it says this is the transversal and two lines are given parallel. If these two are parallel, corresponding angles are equal. What are corresponding angles? F letter. So that means D and F both are equal. According to first one, D is equal to S and C is equal to R. And if you take other way around, P and A equal and B and Q equal. Those are corresponding angles. Then what about alternate angles? Alternate angles are equal. If the two lines are parallel, then alternate angles are equal. So when you take the second one, D is equal to Q. This angle and this angle, Z letter. C is equal to P then, here and here. That's all. Then third one, allied angles add up to 180. What are allied angles? In the internal area, D and P. So we can write P plus D is 180. This one and this one. On this side, C and Q. C plus Q is 180. So you need to remember, if the two lines are parallel, then corresponding angles are equal, alternate angles are equal, and allied angles add up to 180. Now look at this one. These two lines are parallel. So what can you say about these two angles? These are Z letter, alternate angles. So D equals Q. These also parallel lines. So this is alternate angles. So those are equal. D equals Q as well as C equals P. Pair of alternate angles are equal. This is second one. What's that? Corresponding angles, F letter. So D equals S, C equals R. In this diagram, P equals A and P equals Q. Pair of corresponding angles. Last one, allied angles, that's addition is equal to 180. So D plus P 180 as well as C plus D. This should be D. C plus D is equal to 180. So the sum of allied angles is equal to 180. Now find these unknown values using the theorem. When the two lines are parallel, allied angles add up to 180, alternate angles are equal and corresponding angles are equal. So find x. These two lines are parallel, this and this. So that's equal. What type of angles? Alternate angles. This one, y. Y is here. And y and this 130 corresponding angles, F letter. So y is also 130 corresponding angles. This diagram, all these three lines are parallel. This and this Z letter. Alternate angles are equal, so x is 60 degrees. Alternate angles. And y and 120 z angle, that's alternate angle. So y equals 120 alternate angles. Look at this one. Determine the value of unknowns. These two lines are parallel. So straight away, these two are allied angles, add up to 180. So B you can find out. So what's B? 180 minus 130. That's 50. Allied angles. A is here. A is this one. And can we find out C? Here we need to give this line also parallel to that. If this is parallel only, we can find out A. So we'll take this one is parallel, otherwise we can't find out A. So this line also parallel, then what's the A value? A plus 100 is 180. So 180 minus 100 is A. That's 80 degrees. Allied angles. How can we find out C? We can see this is a straight line, ABC on the straight line. So that's add up to 180. So we know A is 80, B is 50. So the sum is 130. 180 minus 130. So you get the C value is also 50. So this is straight angle. Look at this diagram. These two lines are parallel. At once we can take as this is equal to this one, Z letter. Alternate angles. B equals 85. Alternate angles. Then A and this one, these two lines are parallel. So A and 40. Corresponding angles. So A equals 40 corresponding angles. See? Now we can find out ABC on the straight line. So 40 plus 85, you get 125. So 180 minus 125 is C. 55. So 55 degrees for C because of straight angle. We'll take this one. Find ABC. You can easily find out A. Can you see? This is a straight angle. So 70 plus 40, 110. 180 minus 110, you get 70. So A is 70 because of straight angle. Find B. This and this angle, these two lines are parallel. Alternate angles are equal. So B equals 70. See? this and this alternate angles. So C equals 40. This diagram determine the value of unknowns. A. A is here and these two are parallel. So what can you say about A and 60 degrees? Both are equal. So A equals 60. What type of angles? Corresponding angles. I write this symbol to represent angle. B. B is here. This one and this one. These two lines are parallel. B equals 70. Alternate angles. What about C? C, here we can take straight angle. A plus B plus C is 180. So you can find C. So A and B addition is 130. 60 and 70, you get 130. Subtract from 180, you get 50 degrees for C. That's because of straight angle. Then D and C, these two are alternate angles, Z letter. So D is same as C. That's 50 alternate angles. Find A and B in this diagram. These three lines are parallel. Can you see? This one and this one, Z letter. So you can write 80 is equal to A plus 25. Alternate angles are equal. So what's A? Subtract 25. 80 minus 25, you get 55. So A equals 55 because of alternate angles. How can we find B? Look at these two lines. This and this, allied angles add up to 180. B plus 25 is 180. What's B? Subtract 25 from both sides, you get 155. So B equals 155. That's because of allied angles add up to 180. This diagram, these lines are parallel. This with this. What type of angles? Corresponding angles. So A equals 70. Corresponding angles. B is here. These two lines are parallel. So A and B corresponding angles. So B is also 70. So same reason. Find the value of x. This and this, you can get the same because corresponding angles. If this is 7x, this is 7x. Then 7x and 3x, what can you say about this one? This is a straight angle. So we can write 3x plus 7x is equal to 180. What's the reason? Straight angle. 3x plus 7x is 10x. 10x is 180. Divide by 10. X equals 18 degrees. This diagram, look at carefully and see what we can do. These two lines are parallel. This and this, what's the value? A and 70 equal. So A is 70, alternate angles. Try to find out B. These two lines are not parallel, so you can't say A equals B. We know this and this, F letter, that's corresponding angles. So B equals 110. Corresponding angles. C is here. So you can use the straight angle. So I'll take these two. These two straight angle add up to 180. We know 110 is B. So C equals 180 minus 110. 70 degrees we can take as straight angle. Now we'll look at theorem number 4. This is the reverse of theorem number 3. When two straight lines are intersected by a transversal, if a pair of corresponding angles are equal, or a pair of alternate angles are equal, or the sum of pair of allied angles is 180, we can say the two straight lines are parallel. Earlier, there are two parallel lines, the angles are equal. Now the reverse of that. If two lines are there and if you know the corresponding angles are equal or alternate angles are equal or the sum of allied angles add up to 180, that means the two lines are parallel. Now take this one. If this angle is equal to this angle, these are alternate angles. Alternate angles are equal. What can you say about the two lines? AB is parallel to CD because these two are equal. What's the reason? Alternate angles. Look at this diagram. This angle is 110. This is also 110. What are those? F letter angle. Corresponding angles are equal. Then we can say CD line is parallel to AB line. This one, this is 110 and this is 70. Look at the sum. 70 plus 110, you get 180. The sum of allied angles is equal to 180. AQR plus QRC is 180. So these are allied angles. So what can you say about the two lines AB and CD? These two are parallel. If A equals 80, then state whether AB and CD are parallel and give reason. What are these two? Corresponding angles. So if A equals 80, corresponding angles are equal. So we can write corresponding angles are equal. So AB is parallel to CD. This one, if X is 110, what are these? Corresponding angles. State whether AB and CD are parallel. We can say corresponding angles are equal. Therefore, what are the two lines? AB is parallel to CD. Find the value for A, B, C, D. So look at the diagram carefully and identify A. Where's A? Here. These two lines are parallel, so A is straight away 35 degrees. What type of angles? Alternate angles. B. This one and this one equal. We know this is 130. What about this angle? 180 minus 130 because this is a straight angle. So we can find out B from 180 minus 130. That's 50 degrees. You can say alternate angles as well as because of straight angle and straight angle. Because first we can find out this angle and then alternate angles are equal. C. Where's C? Here, this one. This and this, what type of angles? Allied angles. So what is C? 180 minus 120. So C is 60 because allied angles add up to 180. D. D and this one. What type of angles? These two lines are parallel. F letter angle. So D equals 120. That's corresponding angles. Find A, B, C, D, E. Look at carefully which one we can find. A, we can find 180 minus 120 because straight angle. 180 minus 120, that's 60 degrees. That's straight angle. B, these two lines are parallel, so A and B both are equal. Those are corresponding angles. So B is also 60. Corresponding angles. C. C you can find from these two. B and C add up to 180. That's straight angle. So 180 minus 60. That's C angle. That's 120. That's because of straight angle. D. Look at this one. D and this one. Alternate angles. So two lines are parallel. So D equals 70 because of alternate angles. E. What are these two? D and E, vertically opposite angles. Vertically opposite angles are equal. So D equals E, that's 70 degrees because of opposite angles. Look at this one, all three lines are given parallel. This one and this one. We know allied angles add up to 180. So 180 minus 30, you can find out B. So 150 is B because of allied angles. Then what can you say? Here, these two lines are also parallel. So these two allied angles. So 180 minus 40, you get A. That's also allied angles. Allied angles add up to 180. So we found out A and B. So how can you find C? This is a point. Angle around a point is 360. So we can add A and B. That's 290. Subtract from 360. That's 70 degrees. So C equals 70 because angle at a point or angle around a point. Take this one. Determine the values of unknowns. Give reason. So x and y. So these lines are parallel. What can you say about this one and this one? F letter. Corresponding angles are equal. So x equals 30. Corresponding angles. Why? We can look at these two. So this and this angle. Also corresponding angles. So y equals 50. This one, find the unknowns. You get several letters A to H. A is here. This and this. Alternate angles. So that's 30. B. Where's B? Here. I'll use a different color. This and this. Alternate angles. So B is 50. Alternate angles. Next one. C. C is here. So we can see this is 180 straight angle. So what is C? 180 minus 30. You get 150 for C because that's a straight angle. D. D is here. This one. A and D is a straight angle. So how can we find D? 180 minus A value. A value is 30. So you get 150. Straight angle. E is here. This and this add up to 180. So that's a straight line. So what's E? 180 minus 150. 180 minus 50. So you get 130 for E angle. That's because of straight angle. F. F is here. How can we find out F? What's the reason? Here we can take this triangle. The sum of angles in a triangle you know already. That's 180. So this is 50, this is 30, that's 80. F is 100. So F you can write 100 because sum of angles in a triangle is 180. 50 plus 30, 80. 180 minus 80, you get 100. Now we found F. F and G, opposite angles. So that's same. G also 180 because of opposite angles. And H, how can we find H? F and H, straight line, straight angle. So F is 100. So what's H? 180 minus 100. That's 80 degrees because of straight angle. Now look at this diagram. Two lines are given parallel and you're asked to find out these values. So we'll look at it. A plus B, this one, 180. What's the reason? Straight angle. B plus C, again, straight angle, 180. A plus D, this is also a straight line, that's 180. Same reason, straight angle. C plus D, this is also a straight line, that's 180 because of straight angle. K and L, straight angle, add up to 180. P plus Q, straight angle, 180. N plus P. Now you get different type of angle. N and P. Two lines are parallel, so the allied angles add up to 180. So N plus P also 180, but the reason is allied angles. M and Q again allied angles add up to 180. So same reason there. L and M. Straight angle. This is a straight line. So that's also 180, but reason is straight angle. K and N. This is straight angle. That's 180. Reason is straight angle. P and S. Here, this one, straight line. Straight angle add up to 180. Last one, S and R. That's also a straight line. So this is a straight line that's add up to 180. This one, find out A, B, C, D, E. These two lines are parallel. This and this, what can you say? Corresponding angle. So A is 50. B. Now look at this one. This is a straight line. You get 90 here. So A plus B should be 90 complementary angles. So what's B? A is 50. So B is 90 minus 50. You get 40. So you can write here complementary angles. Because this is add up to 90, or straight angle AB 90 on a straight line. C angle here. Now what can you say about these lines? This one. Can you see this is 90 and this is 90. Allied angles add up to 180. So what can you say about this line? This is also parallel to this one. So if this is parallel, you can say C value and 50 are allied angles. So C equals 180 minus 50. So that's 130 because of allied angles. D value. 50 and D. What are those? Z letter. Alternate angles. So D equals 50 because of alternate angles. And E and this are opposite angles. So E also 50 degrees. Opposite angles. This diagram, find X, Y, Z. Two lines are parallel here. These two lines are parallel. Look at carefully and identify X first. Can you see this and this? Allied angles. So allied angles add up to 180. So 180 minus 100, X is 80. Y? Y is here. These two lines are parallel. This and this. Both are allied angles. So what's Y? 180 minus 60. So 120 because of allied angles. Now Z. This and this allied angles for these two parallel lines. So 180 minus 40. You get 140 for Z angle. That's also allied angles add up to 180. In this diagram, find X, Y, Z, M. First X. These two lines are parallel. So this and this corresponding angles. So corresponding angles are equal. So that's 40. Y. This and this also equal. Corresponding angle. So X is 40. So Y is also 40 because of corresponding angles. What about Z? Here, this and this. F letter, corresponding angle. So Z equals to X. So that's also 40. Corresponding angles. And M. Z and M, corresponding angles. So that's also 40. So all are corresponding angles. Review exercise. From the angles given below, select and write the pairs which are complementary. What's complementary means? Add up to 90 degrees. So identify the sum of two angles add up to 90 degrees. 80 and 10. So these two are complementary angles. So what can you write? K angle or J, K, L and what's this one? S, T, U. Those are complementary, add up to 90 degrees. What else? 70 and 20, these two. O, OMN angle and OMN angle and DEF angle. Those are complementary 90-degree angles. What else? Look at these two, 55 and 35. That's add up to 90 degrees. So what can you write? I'll highlight these two. So this angle and this angle. ABC angle and GHI. GHI angle. Those are complementary angles. Based on the magnitudes of the angles shown in the figure, write 4 pairs of complementary angles. 4 pairs. So identify. That should be add up to 90 degrees. Here, 60 plus 30. PQS and RQS. What else? This one, 60 and 30, 90 degrees. PSQ angle with QSR. Part 2. 2 pairs of complementary adjacent angles. Adjacent means next to each other. So I can write same thing. PQS and PQS and SQR. I can write this also, PSQ and QSR. Third one, 2 pair of supplementary angles. Supplementary means add up to 180. Where you get 180? 120 plus 60. So 120 plus 60, 180. I can write QPS plus QRS add up to 180. That's supplementary. Another one, 90 and 90, 180. So you can write PQR angle and PSR. PSR angle. That's add up to 180. Those are supplementary angles. Question number 3. The straight line segment AB, CD and EF shown in the figure intersect at a point. According to this information given in the figure, find the value denoted by A. This and this opposite angle. So what's the value of A? 30 degrees. You can write opposite angles. Give reasons why B equals D. B and D opposite angles. So B equals D because of opposite angles. Find the value denoted by D. So D equals here. D. How can we find out? This is 30 and these two are equal and this is also equal. Okay, so B equals D. We can use the straight angle. Look at this one, this angle. You can write D plus 30 plus B equals 180. But B equals D, opposite angle. So I can write instead of B, this is D. So D plus 30 plus D is 180. That's 2D. Plus 30 is 180. Subtract 30 from both sides. You get 2D equals 180 minus 30, 150. So when you divide by 2, 150 divided by 2, D equals 75 degrees. Then fourth part, find the values denoted by B and C. B we know, B is equal to D. We found D equals 75, so B is also 75. Then how can we find out C? C is same as D, opposite angles. D equals C, but we found D equals 75. So C is also 75 degrees. Question number 4. Name 3 pairs of parallel straight lines. Here, AB and EC or ED. You can write EC or ED. AE parallel to, this one is parallel to BD. Then when you take AD line, this one parallel to BC. Example number 1. In each figure given below, if PQR is a straight line, then find the value denoted by X. So this is a straight line. We know this is supplementary, add up to 180. So you can write 100 plus X equals 180. Subtract 100 from both sides. X equals 180 minus 100. That's 80 degrees. This diagram again, PQR is a straight line. I can write X plus 2X plus 30 is 180. Straight angle is 180. Then like terms at 3x plus 30 is 180. Subtract 30 from both sides. You get 3x equals 150. So what's x? Divide by 3. 50 degrees. So x equals 50 degrees. Example number 2. In the given figure, AQR is 70 degrees and the bisector of PQA is QB. Bisector means these two angles are equal. So I'll put this is A, this is A because of the bisector. If PQR is a straight line, find the magnitude of AQB. AQB is the value of A. We know PQR is a straight line. I can write A plus 70 is 180. Straight angle. Then A and A becomes 2A. 2A plus 70 is 180. Subtract 70 from both sides. You get 110 here with 2A. Divide this by 2. You get A value. So that's 55. So what's the value of AQB? This is AQB value. Exercise 8.1. In each of the following figures, AB is a straight line. Based on the information in each figure, find the value of the angle denoted by the lowercase letter. This is a straight line and this is 90. So what's A? 180 minus 90 because the sum of two angles add up to 180. So A is 90 here. This one APB is a straight line. So 108 plus B equals 180 because of a straight line. So B equals 180 minus 108. You get 100. You get only 72. This one 90 here. So 90 plus C plus 20. That's 180. So this is a straight line. Straight angle is there. 90 plus 20, 110. When you subtract 110 from both sides, you get 180 minus 110. That's 70 degrees. This one, given that it's a straight line, so you can add up 280. X plus 80 plus x equals 180. X plus x, 2x. Subtract 80 from both sides. 2x equals 180 minus 80. Subtract, you get 100. 2x is 100 means what's x? X is 50 degrees. 100 divided by 2. This is again a straight line. This is 180. 30 plus 90 plus m is 180. 30 plus 90, 120. Subtract 120 from both sides. You get 180 minus 120. That's 60 degrees. This one, you get 4 angles. 2x, x, x and another x. That's 180 because this is a straight angle. 2x, x, x, x. You get 5x. 5x equals 180. Divide by 5. You get x equals 36 degrees. Question number 2. In the figure ABC is a straight line. If DBC is 36 degrees, show that the magnitude of ABD. This value is 4 times the magnitude of DBC. So that's 4 times 36. So we'll find out. ABC is a straight line, so ABD is 180 minus 36 because the sum of these two angles add up to 180. What's the value? 144. 144 is 36 times 4. We'll multiply and see. 2, 4 times 3, 12, 12 plus 2, 14. 144 is 4 times 36. So what can you say about this angle? This is 4 times 36 and this is 4 times 36 is DBC angle. 4 times DBC angle is ABD angle. In the figure, ABC is a straight line. Based on the information given in the figure, show that PBR is this one, that's x plus y, is a right angle. But we know ABC is a straight line. ABC is a straight line. So we can write x plus y is 180 because straight angle. 2x plus 2y equals 180. You can take 2 out. Take 2 out from this one. Common term is 2. Or you can divide. We can do this way. Divide the whole equation by 2. 2x divided by 2, you get x. 2y divided by 2, you get y. 180 divided by 2, you get 90. So what is x plus y means? PBR. So instead of that, I can write PBR is right angle means 90 degrees. Question number 4. In the figure, ABC is a straight line. Moreover, PBC is this angle, is equal to CBQ, this angle. Show that ABP is equal to ABQ. So these two angles are equal. So we'll take this one is A. So this is also A. What is ABP angle? ABP angle, I can write ABP angle plus A angle is 180 because ABC is a straight line. Other side I can write ABQ angle plus A angle is 180. Both sides are 180. So according to axiom number 1, if these two are equal, you can write ABP plus A angle is ABQ plus A. According to axiom number 1. Now subtract A from both sides. Subtract A from both sides. So you get ABP here is equal to ABQ. So you get this answer. Example number 1. Based on the information given in the figure, giving reasons, determine the following. The magnitude of DOB, this angle, and the magnitude of AOC, this angle. So we can see both are equal, opposite angles. Now can you see this one? This one is a straight angle. So we can write 57 and BOD or DOB angle plus 43. That's add up to 180 because of straight angle or supplementary if it's a straight line. 57 plus 43, 100 plus DOB is 180. So what's DOB? DOB angle is, take 100 from both sides, 180 minus 100, you get 80 degrees. So what's the magnitude of AOC? It's the same thing because AOC is equal to DOB, that's opposite angles. So opposite angles are equal. Exercise 8.2. In the figure, the straight lines AB and CD intersect each other at O. If AOC, this angle is given 80 degrees. Find the magnitude of BOD. So what's the value of BOD? Straight away you can write down BOD is same as AOC. Opposite angles are equal. Name an angle which is equal in magnitude to AOD. This side, AOD is equal to this angle. What's that? AOD is equal to BOC, or we can write COB. BOC. Question number 2. In the figure, the straight lines AB, CD and EF intersect at O. Based on the information provided in the figure, find the magnitude of each of the following angles. AOC. AOC is here. This angle and this angle, 30. So straight away I can write this is 30 degrees because of opposite angles. BOE, this one and this one, opposite angles. So BOE, I can write this is 100 degrees because of opposite angles. Then COE, this whole angle. COE is this one. This is equal to what? We can use straight angle. Now we found this one is 100. This is 30. Now we know AB is a straight line. I can write 30 plus COE angle plus 100 equals 180 because of straight line or straight angle, or you can say even supplementary straight angle or supplementary angles. 30 plus 100, 130. Subtract 130 from both sides, you get COE equals 180 minus 130, that's 50 degrees. Question number 3. Based on the information given in each of the figures shown below, find the value of each English letter representing an angle. Look at carefully. This and this, what are those? X letter. Opposite angles are equal. 100 equals x plus 35. Subtract 35 from both sides, you get x equals 100 minus 35. 65 is x value. This diagram, look at carefully. A is 38 straight away because of opposite angles. Then, can you see straight line? This one is a straight angle or supplementary angles. I can write A is 38 plus B is 180. Straight angle. (38 plus 2b equals 180. Take 38 from both sides. 2b equals 180 minus 38. 2, 10 for 4, then 142. So b divided by 2, you get 71 degrees. Part 3, you are asked to find the p value. If this is p, this is also p, opposite angles. Now you can take this straight line, straight angle. You can write 2p plus p plus 2p is 180 because of straight angle. 2p plus p plus 2p, you get 5p is 180. Divide by 5, you can get p value. 5 times 3, 15. For 30, that's 6. So p is 36 degrees. This one, you are asked to find m and n, two unknowns. Look at this one. This is a straight line. 90 plus 2m, m and m, 2m. That's 180. Subtract 90 from both sides. You get 2m equals 180 minus 90. That's 90 degrees. Divide by 2. You can get m. 90 divided by 2. That's 45 degrees for m. Then how can we find out n? Look at carefully. This one. You can take this angle with this angle. Opposite angles are equal. X letter. N is equal to m plus 90. But we know m is 45. So 45 plus 90, you get 135 degrees. In the figure, A, B, C, D, D, E and B, F are straight lines. Moreover, A equals D. Fill in the blanks given below to prove that B equals C. So, A equals B. What's the reason? Opposite angles. Opposite angles are equal. D equals which one? C. This is also opposite angle. So, D equals C. Opposite angles. But according to the data, A equals D. Then if these two are equal, According to axiom, definitely we can say B equals C. Question number 5. In the figure, A, B, C, D and E, F are straight lines. Moreover, P equals R. Prove that S equals Q. So we'll write down step by step. We know P is equal to Q. What's the reason? Opposite angles. And also we know S equals to R, or we can write R equals S. That's also opposite angles. But according to data, P equals R. That's given. Now this side is equal. If this side is equal, you can write down therefore Q is equal to S, or S is equal to Q. Exercise 8.3. Consider the figures given below of two straight lines intersected by a transversal. By considering the angles represented by the lowercase English letters in the given figures, fill in the blanks. In the figure 1, A and B form a pair of, this is like F letter. What are those? Corresponding angles. In figure 2, C and D. This is like Z letter. Z letter we call alternate angles. E and F. Here this is like U or C letter. Allied angles. Question number 2. Consider the figure given below of two straight lines intersected by a transversal. Its angles are indicated by lowercase English letters. Name the line which can be considered as the transversal. Where's the transversal? Two lines intersecting line. That's AB is the transversal line. Name the two straight lines which are intersected by the transversal. CD and EF. One pair of corresponding angles is the pair of angles A and E. A and E. That's corresponding angles. Write the other three pairs of corresponding angles in a similar manner. Corresponding means F letter. We can write B with F. B and F. What else? We can write C with G. And if you take D, this one is D, D with H. Those are corresponding angles. Write the two pairs of allied angles in terms of the lowercase English letters. Allied means interior region. In interior region, so we can write B and E. Part 4, I can write B and E are allied angles. Then D and G also allied angles. D and G. Those are the two pairs of allied angles. Fifth one, write the two pairs of alternate angles in terms of lowercase English letter. So alternate angles are Z letters. So write down alternate angles. If you take B, B and G, B and G are alternate angles. Then this way, D and E. D and E also Z angles, alternate angles. Can you find out more? No, only two pairs of alternate angles. Question number 3. Answer the questions given below in relation to the given figure of two straight lines intersected by a transversal. Name the angle which together with ABP forms a pair of corresponding angles. So how can you write? That one is RCB, or I can write BCR. Name the angle which together with BCS, this angle forms the following pair of allied angles. That one is with this one is allied. So I can write CBQ angle. Pair of alternate angles. This one with this one. PBC. Pair of corresponding angles, that means F letter here with this one. ABQ. Now look at the third one. What type of angles is the pair of RCD and PBC? RCD is this one. PBC is this one. What type of angles? F letter. Corresponding angles. This one. What type of angles is a pair of PBC? PBC is this one and BCR. BCR. This one and this one. What type of angles? Allied angles. Example number 1. Based on the information given in the figure, show that AB and DC are parallel. AB and DC are parallel. Look at the values. Look at this and this value. What you get? 115 plus 20 plus 45. What you get? 5 and 5, 10. 1 remaining. 4 plus 2, 8. 4 plus 2, 6 plus 1, 7 plus 1, 8. And you get 1. The sum is 180. So allied angles add up to 180 means those are interior angles. What can you say about the two lines? AB is parallel to DC. So these are ABC angle and BCD angle are allied angles, and allied angles add up to 180. So therefore, what can you say about the two lines? We can say AB is parallel to DC. Example number 2. In the above figure, the straight lines AB and CD are parallel. This is denoted by AB parallel to CD. Moreover, BDC is 75 and BAD is 25. Giving reasons, determine the magnitude of ABE. ABE, this angle. These two lines are parallel means. What can you say about these two? Same angle because corresponding angles are equal. I can write ABE angle is 75 degrees because of corresponding angles. Part 2. Giving reasons, determine the magnitude of ADB. ADB is this angle, this one. What can you say about that angle? We know this one and this one alternate angles. So this is 25. So we can write ADC angle is 25 because of alternate angles. Then we know the sum of these two angles add up to 75. So we can write ADB plus 25 is 75. So subtract 25 from both sides, you get ADB angle is 50 degrees. 75 minus 25, you get 50 degrees. Exercise 8.4. In the figure, AB parallel to CD. PRB is given 50. Find the magnitude of each of the following angles. RSD. RSD, this one. What's the angle? 50 degrees because of corresponding angles. ARS, this angle is 50. What's the reason? Opposite angles. CSQ. CSQ is this one. This one is equal to this angle, so that's 50 as well. I can write that's also opposite angles. I'll write part 3 here because of opposite angles. Then QSD. QSD is this one. Here this one and this one is a straight angle. So QSD, fourth part, QSD is equal to 180 minus 50. That's 130. What's the reason? Because it's a straight angle. Question number 2. Based on the information in each of the following figures giving reasons, state whether AB and CD are parallel. These two angles are equal. So these are corresponding angles. So we can say corresponding angles are equal. So therefore, AB is parallel to CD. This one, this angle and this angle, Z letter. Alternate angles are equal. So therefore, what can you say about that? AB is parallel to CD line. If alternate angles are equal, the two lines are parallel. This one, what can you say? This is 80, so this is also 80. That's opposite angles. And these two add up to 180. So allied angles add up to 180. Allied angles add up to 180. So we can say AB parallel to CD. This one, this is 120. So this one is a straight line. So this should be 60. If this is 60 here and also this is also 60, what are those? Corresponding angles are equal. Corresponding angles are equal. Therefore, AB is parallel to CD. Now look at these two allied angles and see whether you get 180. 95 plus 80, what you get? You get 175, not 180. So we can say AB is not parallel. So here we can cross it out. Not parallel to CD because allied angles not equal to 180. What about this one? This is 130, this is also 130, opposite angles are equal. 130 and 55, what's the value? You get 185. That's not equal to 180. So that's not equal to 180. So we can say this is not 180. AB is not parallel to CD. Not parallel. Question number 3. Find the value of each angle denoted by the lower English letter in the figure given below. Two lines are parallel. So this and this allied angle. So add up to 180. So I can write 110 plus A plus 25 equals 180. Add these two. 135 plus A is 180. So A equals 180 minus 135. So what's the value? 5, 5, 10, 1 remaining. 4, this is 4. So 45 degrees. This one, these two lines are parallel. So this and this both are equal. Those are alternate angles. So I can write 20 plus B is equal to 130. Alternate angles. So what's B? Subtract 20 from both sides. 130 minus 20, 110. Here I'll write down the reason here. What's the reason? Allied angles. This one, these two lines are parallel. So this is equal to this. So C equals 55. What's the angle? Corresponding angles. Then C and D both are equal. So D is also 55. That's opposite angles. This one, these two lines are parallel. This and this alternate angles, or alternate angles are equal when the two lines are parallel. So F you can write 45 alternate angles and E, this and this alternate angles. E equals 60 degrees. Alternate angles are equal when the two lines are parallel. Question number 4. Based on the information given in the figure, show that AB is parallel to EC. These two lines. Look at this one and this one. What's that? Corresponding angles are equal. So what can you say? Those two lines are parallel. Corresponding angles are equal. You can write ABC and ECD. So we can say AB is parallel to CE according to theorem number 4. Miscellaneous exercise. Question number 1. Find the magnitude of each of the angles denoted using lowercase English letters in the following figures. These two lines are parallel. If this is 3x, this is 3x. Then this is a straight angle, that's 180. So I can write 3x plus 2x is 180. 5x equals 180. Divide by 5, you get one angle x, 36 degrees. And this one, three lines are parallel. If this is 3p, this is 3p, corresponding angles. If this is 2p, this is 2p, again corresponding angles. Now we can see this is 130. 3p plus 2p equals 130. So 5p equals 130. Divide by 5. You get P angle. That's 5 times 2, 10. For 30, that's 6. So 26 degrees for P value. Question number 2. In the figure, X, Y and Z denote the magnitude of the relevant angles. If X plus C is equal to Y, find the value of Y. Look at the diagram. X plus Y plus C, 180. Why? This is on a straight line. So straight angle. X plus C. So this and this, I'll rearrange this. X plus C plus Y is 180. Here, these two, X plus C is given Y. So Y plus Y, 2Y. 2y equals 180. So what's y? Divide by 2. 180 divided by 2, you get 90 degrees. So the y value is 90 degrees. Question number 3. Based on the information in the figure, write the values of DCE, this one, and ACD, this one, in terms of x. These two lines are parallel. This and this, what are those? Corresponding angles. So I can write DCE is 3x. The reason is corresponding angles. ACD, these two lines are parallel, so this and this alternate angles. So ACD is equal to 2x. Alternate angles. Now find the value of x. We found these two. Now we can take, this is a straight angle, this one. So I can write 4x plus, this is 2x and this is 3x. That's equal to 180 because this is a straight angle. Now 4 plus 2, 6, 6 plus 3, 9x. 9x equals 180 divided by 9, you get 20 degrees. So x is equal to 20 degrees. So the third part, find the magnitude of each angle in the triangle. So A angle is 2x, 2 times 20, that's 40 degrees. What about B angle? 3x, 3 times 20, 60 degrees. And C angle is 4 times 20, that's 80 degrees. Question number 4. Write all the pairs of parallel lines in the given figure, indicating the reasons for your selection. Look at carefully. These two are not parallel, 40 and 45 not parallel. When you take this one, 45 and 25, 70. And this is also 70. Alternate angles are equal. So BC is parallel to EG. That's one pair. Then what else? What about when you add 15 to that? Here 15, 15. So you get same alternate angle. This whole angle, when you add 15 to that, and this one, both are equal. So AB is parallel to EH. So those are the two parallel lines. Question number 5. In the figure, ABC is P. CDE is Q. Show that P equals Q. Now, look at the diagram. These two are equal. So I can say this is P, this is also P. Alternate angles. And it says this is Q and these two also equal because these are parallel lines. So obviously P equals Q. So we'll write down ABC angle is equal to BCD angle. That's P. You get, when you look at these two, you can write BCD angle is equal to CDE angle. This is Q and this is P because of alternate angles. So we can say these two are equal. So this is P because of alternate angles as well. So we can say P is equal to Q. So we covered all theory related to angles. So what are the things we discussed? Sum of adjacent angles formed by a straight line meeting another straight line is two right angles. So straight angle is 180. The vertical opposite angles formed by the intersection of two straight lines are equal. So opposite angles always, those are equal. When two straight lines are intersected by a transversal, if a pair of corresponding angles are equal or a pair of alternate angles are equal or the sum of pair of allied angles is 180, what can you say about the two lines? The two lines are parallel. This is theorem number 4. What about this one? When a transversal intersects a pair of parallel lines, then corresponding angles are equal or alternate angles are equal and the sum of allied angles add up to 180. That's theorem number 3. So practice all these exercises and examples and thorough with the angle section.